Today I thought I'd do a video on testing procedures for distributors. Today we're testing a 1964 Cadillac 429 distributor, distributor number 1111061. I rebuilt this for a customer and he wants it completely stock, so we're going old school with ignition points and a condenser. It has an original Delco Ramey 1116 227 vacuum advance with 20 degrees of advance at the crank. And the first thing I want to talk about here is we are doing our testing on a 1973 Sun 504 distributor tester. I'll give you just a quick overview of the distributor tester. The upper right hand meter is your dual range tachometer. Low speed scale on the top, high speed scale on the bottom. This is your dwell meter for 4, 6, and 8 cylinder. Has a calibration position and a calibration dial for calibrating your dwell meter. The upper right hand meter is your condenser meter. The upper scale is capacity in microfarads. The lower left hand scale is your leakage scale, the black bar. And the lower right hand scale, the black bar, is your series resistance. Now you have a 3-position knob for your condenser meter, leakage, series resistance, and capacity, and your calibration dial, and your vacuum regulator valve. You have a separate vacuum switch which runs independently of the machine for your vacuum pump, and a directional switch, left hand or right hand, depending on whether your distributor turns clockwise or counterclockwise in the engine. And your switch for your dual range tachometer. Now the first thing we're going to do is calibrate our condenser meter. So we hook our leads together. The needle sweeps to the end. We're on the set line. It's adjusted properly. So we'll hook one lead to the distributor lead and the other lead to our condenser. Now you notice the needle swings into the black range on the lower portion of the scale. That's the series resistance. That's where we want to see it. We wiggle our wire. The needle doesn't move, so we know our wire isn't broke inside the insulation. So the next test we're going to perform is our capacity test to make sure our points are open. And our capacity, the needle swings down to 0.22. The spec is 0.18 to 0.23 microfarads, so we're within spec on our capacity. The next test is leakage. And our needle rockets right to the bottom of the black scale. That's what we want to see. If that needle was in the midpoint in the black or the upper portion of the black, I'd take a heat gun, warm the condenser up to operating temperature would be around 100 degrees, maybe a little better. And as the condenser heat soaks, the needle would creep up into the blue range and keep creeping up while it's heat soaking. That's telling me the condenser is bad. The leakage is too high, the condenser needs to be replaced. If it fails any of those 3 tests, it needs to be replaced. A quick tip on condensers: there's a lot of new old stock condensers on the internet. If you buy 10 condensers and test them on this meter or a Graham coil condenser tester, which I also have, 8 out of 10 of those condensers will fail the leakage test. And you say, why? They're new. They're new old stock, but they're old. They're 30, 40, 50 years old. Go to your parts store, buy a condenser, or better yet, go to GM and buy their reproduction condenser that is GM certified. Every time I've tested one of those, they've always been good. I've never had a bad one. So the next thing we're going to do, next test we're going to perform is a distributor resistance test. First thing we're going to do is calibrate our dwell meter, make sure that's within calibration. In the calibration mode setting, turn our calibration dial to the set line so we're calibrated. Hook back up to our ground and our distributor lead. We're going to close our points. And our needle goes deep into the black range. That's what we want to see. That's telling me our ignition circuit has low resistance. What does the ignition circuit consist of? Our coil wire, our ignition point assembly, the breaker plate, the distributor housing, and ground through the engine block, or in this case through the distributor machine. Now if we had high resistance in the circuit, where would we start? We would disconnect the coil wire, take our lead, hook it to the other end of the coil wire. If it's in the black range, we know the coil wire isn't the problem. Touch the breaker point assembly. We're in the black range, that's not the problem. Check the breaker plate, it's in the black range, that's not the problem. Check the distributor housing, in the black range, not the problem. So if we have high resistance, and none of these show high resistance, where is our high resistance coming from? It's coming from the contacts themselves on the point assembly. They're either corroded, or they're contaminated by oil or something else. Corrosion usually occurs if a vehicle sits for several years. You take a point file, run through the points to remove the corrosion, spray them down with contact cleaner so you can get them back into that black range. And while you're doing that, you can look at the points and see if they're badly pitted. If they're badly pitted, you should probably replace them anyway. So that's the distributor resistance test. Now next test we're going to do is going to be our breaker point spring tension. Since we're going totally old school on this Cadillac with points, we need to know what our spring tension is. So we put our spring gauge on, and you notice as I pull it, the light will flash when we get to the measurement for the spring tension. We're at 23 ounces. When you saw the flash, so we're within spec. The spec is 19 to 23 ounces on our breaker point spring tension. So the next test we're going to do is our breaker point cam lobe accuracy test. There's a lobe for all 8 cylinders which opens your breaker points. They're 45 degrees apart. I will put it in the low range on our dual range tachometer. Bring our RPMs up to 1,000 RPM. We'll adjust our degree wheel to 0. And we look at all our other arrows around the degree wheel, and the spec is plus or minus 1 degree. They're all within spec. So our breaker point cam is in good condition. We'll re-zero our degree wheel. I've seen distributors where we have 1, 2, 3 cams that are worn, lobes that are worn on the cam. They'll be off anywhere from 2 to 5 degrees. Will it run that way? Yes, it will. But it will not perform at peak performance, because 2 or 3 cylinders, the timing is firing 3-4 degrees off from 45. So the timing is varied on 3 cylinders, or how many lobes your cam is worn. So what you would have to do is find another used breaker point cam, because they're not available new, and test that. Or if you have an ultra rare distributor, you could buy a Pertronix 2 ignition. They have the magnets which trigger the Pertronix buried in the wheel that's bolted in underneath your rotor. and they're generally at 45 degrees, so that would return it to spec if your breaker point cam is wore out of spec and you can't find one to replace because of the rarity of your distributor, or you just can't find one. So the next thing we're going to do is we're going to look at our point alignment. I don't know if you'll be able to see that on the camera, but there's your contact points. They look nice and square. See, they're open, now they're closed, they're nice and square. Another way to tell is when you're running the distributor, the camera won't pick it up, is you'll see a slight arc between your contact points. If it's in the center of your contact points, your points are adjusted, the contacts are adjusted properly, they're square, so the arc is in the center. That's what you want to see. If it's off to either edge, they need to be adjusted. Either the stationary contact needs to be adjusted, which is most of the time if adjustment is required, or the breaker point arm, and you would use tools like this for adjusting your breaker point contacts. Now the next thing we're going to do is set our dwell. We're in the 8-cylinder position. Currently our dwell's at 30 degrees and the spec is 28 to 32, so we're within spec, but I'll show you how it's done. We're at 34 or 35 degrees. We'll bring it back down to 30. That's where I set them. It's 30 degrees. We're at 30 degrees dwell. The next test is the dwell variation test. Now the spec on the Sun specification card for 64 Cadillac is 2 degrees max variation. The RPM range is 0 to 1750 RPM, or 3500 engine RPM roughly. That's what the distributor sees for RPMs in a street driven car if you were driving it to work every day. So we'll switch to our high-speed scale, the lower scale on our dual range tachometer. Bring our RPMs up. We're at 1750. We have 1 degree variation in our dwell. Spec is 2 degrees, so we're within spec. Peak horsepower on a 64 429 Cadillac is 4,600 RPM, 2,300 distributor. We're at 1 degree. We're within spec. We'll take it to 5,000. The Cadillac would rarely see 5,000 on the street. We're just a shade under 1 degree. When I touch it, it gives me some static electricity and that makes it move. But we're at 1 degree right now. So we're within spec. We're okay. We're about just a shade under, about 1.25 degrees. So that tells me that our distributor shaft and bushings are in good condition, and the breaker points also affect, the breaker point spring tension also affects how much the dwell changes. If you've got a weaker spring, the dwell will vary more. If you've got a little stiffer spring, like this one is at 23 ounces, it doesn't change as readily because the spring tension is making those contacts close properly, so your dwell doesn't vary as much. With a weaker spring, you have less wear on your breaker point cam. So on a street-driven car like this, if it varied 2 degrees, it's still within spec, and it would be fine. Even with the little weaker spring, it's not like it's a performance car where you're twisting the thing to 5,500 or 6 grand, and you want to make sure your dwell doesn't vary. Now the next thing we're going to do is do a breaker plate test. The rod from your vacuum advance makes a 90 and comes through this hole in the breaker plate, and that pulls your vacuum advance. Your vacuum advance advances your breaker plate, which changes your ignition timing. Now we'll turn on our vacuum pump. We've got our degree wheel zeroed. We'll apply some vacuum to the vacuum advance, and you can watch it advance. It's nice and smooth as it moves. It's not jerky. If your hole is worn in your distributor plate where the vacuum advance connects, your breaker plate will jiggle on that post that comes up through the breaker plate, and you'll see the needle bounce around a little bit. It'll bounce around a degree to half a degree depending on how worn the hole is. It also lets you know if your ground wire is broke under the insulation, because the needle would jump around, or the arrow, or it would disappear because you're losing your ground. So we know that's all good. Now the next thing we're going to do is a vacuum advance test on our vacuum advance unit. Cadillac has 8 data points. Other GM divisions only have 2 to 3. They may have a starting vacuum point, a midpoint, and an ending, but Cadillac wanted it more precise, so they've got 8 data points for the vacuum advance. So we'll turn the vacuum pump on. First spec is 5 inches, and the spec is 0 degrees. We're at 0 degrees, we're within spec. The next spec is 7 inches. We're at 7 inches, and the spec is 0 to 1.5. We're at 1 degree, we're within spec. The next spec is 9 inches. We're at 9 inches. The spec is 1.5 to 3. We're at 3 degrees. We're within spec. The next spec is 11 inches. We're at 11 inches, and the spec is 3 to 4.5. And we're at 4.5. We're within spec. The next spec is 13 inches. We're at 13. The spec is 4.5 to 5 3/4. Let's make sure we're there. We're at 5 3/4 on our spec. The next spec is 15 inches. We're at 15, and the spec is 5 3/4 to 7 1/4. We're at about 7 1/4. The next spec is 17. Wants to creep up on me a little bit, so it doesn't always stay where I want it to. We're at 17, and the spec is 7 1/4 to 8 3/4, and we're about 8.5 degrees. So we're within spec. The final spec is 20 inches. And the spec is 9.5 to 10. And we're at 10. So we're within spec. Now the next test is going to be centrifugal advance. We'll return our dual range tachometer to the low range. Make sure our degree wheel is zeroed. Our first data point is 450, and the spec is 0 to 1.5 degrees. We're at 0 degrees yet, so we're within spec. Our next RPM range is 600. The spec is 3/4 to 2 3/4. We're at 2 degrees advance. We're within spec. Next is 800 RPM. Spec for 800 RPM is 2 3/4 to 4 3/4. and we're at 4 degrees. We're within spec. The next spec is 1050, 1050, so we switch to the low scale, which is the high speed scale. We're at 1050, and we're at 6 degrees, and the spec is 5 to 7. So we're within spec. The next is 1200 RPM. We're at 1200 and we're sitting at 6.5 degrees, and the spec is 5.5 to 7.5. So we're within spec. Next is 1400. We're at 1400 and we're sitting at about 7.5 degrees. Spec is 6 to 8 degrees, so we're within spec. Next is 1600. We're sitting at 8 degrees at 1600 and the spec is 6 to 8, so we're within spec. Next spec is 2000. Spec is 8 to 10 at 2000 and we're at 9.5. We're going to bring it to peak horsepower on a 429 Cadillac, which is 2300 distributor, 4600 engine. We're at about 10.5 degrees, so it's an overachiever. It's a half a degree over. It does have the proper rubber bushing installed. I've seen this before where they're over just a little bit or under. It won't affect the performance of the car because it doesn't spend any time at that RPM range at 4600. On a street driven Cadillac like this, it would rarely see 4600 RPM. So the next test we're going to do is a cruise RPM test, which is centrifugal. We test the centrifugal advance and the vacuum advance and combine the two. So according to the Sun Spec card, 31.5 to 36 for both centrifugal and vacuum, 11.5 to 14.5 for centrifugal only. We'll bring our RPMs up to 1250, 2500 engine. We're at 7 degrees. That's 14 degrees at the crank. We're within that specification number for centrifugal advance. Now we'll add some vacuum advance. We're at 17 degrees, centrifugal and vacuum. Remember that doubles at the crank? That gives us 34 degrees, so we're within our spec of 31.5 to 36. Next test we're going to do is a point float test. We'll bring our RPMs up. We're at 5,000 RPM, 52, 54, 58, 6,000, we're still within spec. 62, 64, now the dwell's going away because we got point float. Now you're getting to see an extra arrow occasionally, the points are floating. We'll take it to point bounce. Now we're getting extra arrows all the way around. We're at 7,000, our points are bouncing. And our dwell is way out of spec. This street-driven Cadillac will never see those kind of RPMs, but I wanted you to see what point float and point bounce look like. I hope you've enjoyed this video. I do distributor work for people, rebuilding. I bought out a Delco Ramey distributor engineer 10 years ago, so I've got a pretty extensive inventory of springs, weights, HEI parts. I've got 110 different HEI advanced cams. Some weights, I'm kind of getting depleted on some of my parts. I've got the rubber bushing that goes in these Delco point distributors. It's always gone. And I hope you've enjoyed this video and learned something new, and I hope to post some better videos of a disassembled distributor and where to look for wear points and what to replace, and I'll do that in the future at some point. So I hope you've enjoyed this video, and that's it.